7 Years of Blazor with Shaun Walker.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by TrailBlazor, a full-service software architecture and engineering firm that serves companies using .NET and Azure. We build mission-critical software systems, rescue failing projects, empowering software delivery with a proven approach. I am excited to announce that my latest book is now fully released. The book is about software leadership. It's called The 5 Pillars: Leadership for Effective Custom Software. The book is for anyone who's attempting to make a custom software team highly effective. And so if you want your team to deliver world-class results, this book could be for you. Teams are also doing book studies and discussions around it, and I'm excited about that. And if you, dear listener, would like a complimentary electronic copy of the book, just send me an email and I'll get it to you. The email is in the show notes. And for those of you who are in a lead architect or software executive role, you might want to join our monthly forums. These are interactive and deeply technical sessions that I enjoy facilitating. They're peer conversations over Zoom video call. You can sign up on clearmeasure.com. And I've also just launched a new lead engineer live stream on youtube.com/clearmeasure. For any software engineer looking to be successful as an engineering lead on a software project, I'll cover topics that are essential for that software lead role and answer questions. So subscribe to the channel at youtube.com/clearmeasure, and you'll see the live stream schedule. Now, my guest today on the show, returning guest, is Shaun Walker. And he's the founder and CEO of Devessence, a global technology consultancy with a boutique approach. He's also the founder of the Oqtane and DotNetNuke web application frameworks, which have earned the recognition of being amongst the most pioneering and widely adopted open source projects native to the Microsoft platform. He has over 30 years of professional experience in architecting and implementing enterprise software solutions for private and public organizations. And he also supports the TrailBlazor Conference, which we'll talk about. But Shaun, welcome back to the show. How are you, sir?
I'm good. Thanks for having me back again. When I hear my bio and I hear 30 years professional experience, it makes me feel pretty old.
Well, that's probably because the text hasn't been up. I mean, when does it tick over to 35? Pretty soon, I would imagine.
Hey, slow down.
Well, no, actually, I want the listeners to understand that because there are a lot of software engineers who are kind of going through the first 5 years of the programming career. And I certainly remember, I'm sure you remember what it was like those first 5 years. And then even after that, what it was like to get to year 10 and what things you're just trying to get good at versus the perspective you have now.
Yeah. So my first 5 years, that would have been in the 90s. That would have been, I think when I came out of university, I hadn't even experimented with Windows yet.
Mm-hmm.
So a lot of my university training was all on mainframe or DOS-based systems. So yeah, it was so it's interesting. Like as a software developer, I'm sure that people who are entering the market right now are hearing a lot of messaging that, things are changing very rapidly underneath them. And,
Sure.
you're going to have to keep learning new things and AI is going to like make a big
Sure.
dent in your career. And
Yep.
actually, when I look back, I was going with the transition from mainframe to Windows, and I was thinking the same thing. Like, I'm already out of date. I need to learn new things immediately as I start my new career. And I think that that's always going to be the case. And so you can like obsess about the various risks that could impact your ability to be successful, or you can just dive in and learn new things and be versatile and adapt. And that's, I think, the only way that you're going to really be successful in the long term. Because
Yeah. Yeah.
yeah, the storylines are always going to somewhat concern you about technologies changing in ways that you might not be able to adapt quickly. But I think that as human beings, I mean, if you're intelligent enough and passionate enough, you can definitely like adapt very quickly.
Yeah, that's the word. I remember like in the 90s, I was still kind of doing side projects and university courses in the late 90s. And there were these things called case tools that are ancient history now, but as part of the curriculum because supposedly case tools in UML was supposed to make it to where anybody could describe what a software program should do, and then we wouldn't need programmers to actually write the code. Well, obviously that
Yep.
didn't pan out. But I mean, just remember how long it was when the big dust up about citizen programmers and the Power Platform. Well, it's awesome for what it does. Some of them, some of the marketing attempted to say, and now you won't have to write so much code because you can click and drag and drop in the Power Platform and all that. And while hey, it's another good tool when you need that tool, but none of these eras of things that attempted to say so that you won't have to write as much code and won't need as many developers out there. None of them ever pan out, and I don't think it ever will. And the same thing with AI, which well, it's if you're listening to this show, it's already passed. But we did a lead engineer live stream on AI tools and what every software engineer should be running locally and just playing around with all the different open source models and how to do it and what it looks like and just to figure out where you might put it into a software application. It's just another tool. And yeah, we're all going to use it where it makes sense, but you're still going to write a whole lot of code.
Yeah, no, I think you're right about that. And that's the way you should be looking at it, is just another tool. And like any tool, you can use it to the maximum or you
Hmm.
can ignore it. Right?
At your
Some maybe
peril.
at your peril, but
Right.
well, because it's more because other people are going to suggest like, why aren't you using this tool, because it can make you more productive. And of course, if you find the right techniques, then yes, usually that is the case. But like you said, there's like been so many tools that have come and gone as well. When you're mentioning case tools, I remember fourth generation languages, and like, so all of these things had like the premise that it was going to make developers kind of obsolete, right? It
Yeah.
was going to allow people to just describe what they want and then magically a product would be produced. And I think for those of us who have been developing software applications long enough, you realize just how much complexity there is in building a viable product.
Hmm.
And it's definitely more than just the source code. Like there's far more that goes into a software application than just the code itself. And yes, maybe AI can help you write some snippets of code right now that actually work, but to stitch those all together into a complete enterprise application, like we're a long ways from that ever being possible.
Oh, for sure. For sure. Well, it's probably easy to keep on talking about AI and because the conjecture of okay, what's it really going to do? It's hey, it's something awesome and new, and everybody's learning it and adapting it. And but at the same time, 10 years from now, it'll be something else.
It's interesting because I was talking to another developer recently, and he's working at one of the big four accounting firms. And like at the enterprise level, I think that there is a lot of interest in these tools because the management believes that it can save them perhaps a lot of money
Hmm. Yeah.
in terms of like software development effort. And so they're really looking closely at these tools and trying to figure out like if there's a good path forward. And he said, so what about your clients? Are they asking for AI? And I'm like, my clients don't even know what source control is. So
Yeah.
like there's a huge gap in like the mainstream messaging around AI and then what the reality is on the ground of just companies that wanted just do some basic digital transformation. Like
Hmm.
there's still a lot of companies that are way behind in terms of using technology.
Yeah.
And
Yeah.
people, I think, sometimes forget that.
Sure. Sure. Well, speaking of ways of technology, this year I was just counting it up from 2018. We're in year number 7 of Blazor's release. And from when Steve Sanderson kind of put it a part of .NET Core 3.1 and the first iterations, And you've done just a massive amount with Blazor and Octane framework, which I want to ask you about. But just kind of looking back, what was it that made you look at it and say, yeah, this out of all new projects that come along, this thing has legs?
Yeah, so I think so. I think it was 2014, right, that .NET Core came out, and I had been kind of following along .NET Core. I'd even done like a few little projects in it. And then I think it was early 2018, maybe. I actually got a text message from Scott Hunter who had said, "Have you looked at this Blazor stuff that we're doing? You know, it's still experimental, but it's got a great component model, and it's something that I think you'd be quite interested in based on the history of, how you had built a content management system using web forms, right? It's got
Yep.
a lot of
.NET Nuke.
yeah, that component capability that was part of web forms that was quite useful in terms of building a very dynamic, like content management type application. So I took a look at it, and I immediately saw that it had some amazing potential as well. At the time, I wasn't so caught up in like the different hosting models, WebAssembly versus server. I saw that the core of it was this really powerful component model, which allowed you to kind of abstract logic, um, encapsulate it, package it up, and then reuse it in a variety of different ways. So and that architecture has really been like the foundation of Blazor since the very beginning. And it's allowed it to do so many things. And like you said, the last 8 years, there's been, so many improvements over that time. But getting involved in like 2018, where it was still somewhat experimental, not even part of like .NET 3.1 yet.
Mm-hmm.
It was a little challenging. The documentation wasn't great. There was a lot of experimentation required just to see how things worked. Um, it was confusing in terms of like the runtime characteristics of it. If whether you wanted to run it using WebSockets and SignalR and on Blazor Server, or whether you wanted to dive into WebAssembly. Um, just there was like a lot of interesting capabilities there, and it took a while to wrap your head around it. But what I really liked about Blazor was that the team had like this vision, like this roadmap that they were thinking of right from the very beginning, where they saw that it could do many different things. And so they saw that it could run in different ways, and they saw that it could be also used as part of Maui, right? And
Mm-hmm.
and then they later adapted it to being able to do static rendering as well. And just it's the way it's adapted, it is so powerful and so versatile that it can do so many things. Um, but I think at the same time, with all of that power, it's become a little bit more complex for new developers to come up to speed on. Like there's just a lot of choices that you need to make up front, and you don't, unless you've done a bit of research, you don't really understand, you know, what the path should be
Yeah.
based on your requirements. So it's a little bit daunting for new developers. In fact, I just saw like a little thread on GitHub in the ASP.NET Core repo where some developers were um, complaining a little bit about the fact that Blazor is so powerful that it's become challenging for new developers to come up to speed.
Yeah. Yeah. Well, it seems like it's a totally different way to tackle a web application than, say, Angular. Now, when you say Angular, we're just you can't say one thing, because if something was way back in Angular 1 and 2, the early versions, and then several rewrites, it's like it might be called the same thing, but it's totally different
Right.
versus the kind of the last major versions. But it seems like that comes very much from CSS, HTML, and then some support for business logic and calling web services and other things. But whereas Blazor, you're sitting on top of the whole .NET stack. And if you're talking about a database or web service call or integrating with Twilio or PayPal, all these other services, you don't even need to talk Blazor. You're just talking .NET.
Right.
But then when it comes to what do we want to show in a browser, now we're talking about Blazor. Whereas when I look at in the conversation with React and Angular, there's so many there's so many other normal things that we wouldn't even associate Blazor with, but people stay in Angular and React land to do other things. And then I've seen too many times, yet again, too much logic that's tightly coupled to the user interface layer, which is that's been a problem since the 90s.
Yeah, yeah, you're right about that. I think it's because developers just naturally will implement things in the environment that they feel most comfortable. And so if you're a React or an Angular developer, it just seems that's your hammer. So that's where you're going to do all your work, whether it makes sense to do it there or not, and whether it creates, longer term maintenance problems for the application. Like you said, that's another whole story. But you're right. With at least with Blazor, and the fact that you have the whole .NET environment available, you can, it's just got so much power, right, and so much capability. And it is all one big sort of integrated story, um, using a, a common set of tools and a common sort of development environment to make it all work well together. So that is definitely one of the strengths of Blazor.
Now looking back since that 2018, I think I have that date right, don't I? .NET Core 3.1.
Yeah, I think that's when they decided that they would actually make it official
Yeah.
and pull Blazor into the .NET Core distribution. And you're right, I think it was .NET Core 3.1, which they finally shipped the first version of Blazor, and that was Blazor Server, which actually shocked a lot of people,
Yeah.
because initially it was all about, oh, Blazor is all about WebAssembly, right? And the
Mm-hmm.
two were sort of linked together as kind of being synonymous. And then, as it turned out, there were some technical challenges that needed to be ironed out when it came to WebAssembly. And so Microsoft realized, oh, well, this technology can be used with SignalR to drive a user interface over like a WebSocket connection, and that works really well. And all that tech has already been built, so we can ship that first. And in fact, I think it's interesting because I think there was a lot of people who basically thought that that model was not going to be successful and not going to be scalable. And they thought that as soon as the WebAssembly version of Blazor came available, that all developers would kind of shift over and just start building applications on that model. But what I've seen is it's still pretty much a 50-50 split.
Yeah.
Um, Blazor Server is really like a great environment to build, especially internal apps. Like if you're building an application for inside of your own business, um, and you don't have to deal with sort of the public, internet and latency and all that, it works great. Like it's super responsive. If you're building a consumer facing application, then more likely you're going to want to use WebAssembly. But um, yeah, it is interesting how it's evolved over time.
Well, that's a key thing. I want to dive into that because I think that's important architecturally. Because right early on, it was just the Blazor server side, and so the documentation and the early blog posts and articles, it was all server side. So still, when you go online and search, I'll stumble on all kinds of material that would almost lead the new Blazor developer to think, oh, this is the one. Yeah, this is the preferred one. Whereas today, that's only because they had a good head start. But you mentioned a consumer app versus an internal app, WebSockets. What is it, in your opinion, that is like the architectural fulcrum where you would say, oh, okay, over here, yeah, Blazor Server is better, and this is why. Over here, Blazor WebAssembly is better for this scenario, and this is why.
So, and this kind of leads us to, like up to like .NET 8. Microsoft introduced static Blazor as well as yet another sort of flavor of Blazor that you've got to consider when you're building something. And so if you are building like a website, for example, right, which contains a lot of static content and is going to be public facing and it's going to have a lot of anonymous visitors hitting it, static Blazor, which is what Microsoft introduced in .NET 8, is definitely the best choice for that. It's just much more scalable and doesn't rely on any other technologies such as SignalR or WebAssembly, right? It just relies on traditional kind of web concepts, right, to drive your application. Um, then the next thing that you kind of have to look at is, are there areas of that application that are more interactive in nature? And that might be, once a user logs in, they might have a dashboard, or they might have, administrative kind of capabilities that they need to access. And by nature, those are interactive. And so once you have kind of carved off those areas of your application and identified them as interactive, then you have the choice to make of whether or not they should be using, WebAssembly or Blazor Server, which is SignalR. And I guess if that interactive portion of your application is still going to be consumer facing, then it would make sense to use WebAssembly for that. Whereas if it's going to be more internal, I believe, then Blazor Server is great for that. But those are not hard and fast rules, because I've seen,
Mm-hmm.
very powerful websites running Blazor Server, right? You just have to kind of scale up the SignalR connection availability, and it can still serve it in that way. And so there is still no defined rules, but there's sort of like, I guess, guidelines that you can follow.
Yeah. Well, from one of the learnings that I did early on, it was in 2020, and the debugging tools for WebAssembly still weren't good in Visual Studio, and so I started a project in server side, and because I ran it in Azure, I didn't have any problem with the number of WebSocket connections. Whereas, yeah, if I had my own single server, okay, maybe I'd have saturation on WebSockets. I don't actually know what number that is, but architecturally, it's a lot lower. But with Azure SignalR service, it's like it wasn't even a concern, and it wasn't expensive at all. It was, I mean, it was one of the cheapest services on the bill.
Yeah.
But what was the most expensive was because every single user's session was using my CPU and my memory in
Yeah.
Azure, because I was using Azure App Services. I had to scale up the instance size, and I had to add multiple when I had heavy usage times. And that right there, it was more financial. I mean, it worked great. Functionally, it was perfect, fine, great, no issues there. But I wasn't happy with the cost. And so architecturally, because every time someone clicks a button, loads a page, they're using my CPU and my memory in Azure, and I'm paying for that. Architecturally, that flipped my head to say, okay, no. If I have a lot of people, just economically, I want to basically the same architectural model as React and Angular, which is run all that code and logic in the browser, use their CPU and their memory.
Yep. Yeah. And like Static Blazor allows you to do that, right? It allows you to leverage the power of, the client, and not utilize like server resources for every single visitor to your website or application. WebAssembly also allows that, but WebAssembly comes with a little bit of a penalty in terms of like the first time a user accesses your website or your application, it has to download assemblies, right? It has to download the bits of your application, and that can produce a little bit of a slow user experience the very first time they access it. From that point on, it's cached, so it'll be very fast. Actually, it'll be super fast because it's almost running like natively in the browser.
Yeah.
But it's a lot of people get kind of caught up on that initial response time, right? For a first time user.
Which that's odd, because you look at the popularity of that Angular, React, and Vue have had over many years, and it's all over the web. I mean, that model of, the very first time a user goes here, okay, there's actually a lot of JS files being downloaded.
A ton.
And yeah, so it takes, but so for that to be an architectural argument to say, and therefore I don't want to use it, well, that argument would disqualify Vue, React, and Angular as well as options, I would think.
Yeah. I think it's funny because as technologists, it's easy to be a critic. Like, it's easy to kind of stand back and point out the limitations of technologies without actually using them, right? Because and I found that a lot with Blazor is people will point out the unique little like limitations of each approach, but they've never actually built an application, like a serious application on Blazor. And because if they actually had, they probably would have realized they wouldn't experience any of those pain points they're criticizing.
Mm-hmm.
So it's kind of a weird anomaly. And I mean, it's not just with Blazor, it's other types of technology as well. It's just, it feels like the first thing that technologists like to do is find the weakness, right? And
Yeah. Yeah.
talk about it.
Well,
Yeah.
the initial load problem, I think that pattern has been solved in all of the SPA frameworks by having the first page, which intentionally doesn't have any code that loads the bulk of the dependencies, but it renders pretty fast, not noticeable. And just by having that page render fast, and now they're reading the text, it could be a login page, could be a home screen of some sort, but then the last bit of logic on the page after load is something that does trigger the dependencies and then cause, after the user is looking at something on the screen, now we start loading the other dependencies so that, we do it, but they don't even notice, because by the time they hit the second click, it's loaded.
Yep. Yeah, and that's something that Blazor always had almost from the very beginning, is this kind of notion of pre-rendering. So you could pre-render the initial version of the output so that the user would have something to see, and then the interactivity would kick in after that. From a software development perspective, that had some interesting characteristics to it, because your code had to kind of take, or at least be cognizant of the fact that there's like sort of two renderings that happen. There's an initial rendering on the server, and then there's an interactive rendering that happens later.
Yeah.
And then later, I guess in .NET 8 and of course .NET 9, Microsoft has also introduced like new capabilities around this called auto render mode, right? Where if you have an interactive component, you can actually, you can have it so that it renders using Blazor Server initially, which is very fast because WebSockets can be spun up very quickly. And then in the background, it downloads the WebAssembly bits. And then on a subsequent request, it'll flip over and start using the WebAssembly kind of natively in the browser, which is kind of a cool concept. In reality, there's some challenges to make that all work effectively when you're writing the code, because you can't, because this is one of the things that I think people who have worked on Blazor have kind of bumped into, is that if you're building a Blazor server application, you're running on the server. And so you have access to server resources. So you can just like call a database directly from your component.
Right.
And it's super fast, and you can write code really quickly that way. Then you try to run that same code in Blazor WebAssembly. And in that context, it's a true client server.
Yep.
Like it's,
Not
and so
happen.
you don't have access to those server resources. And of course it's going to blow up. And then you realize, oh, okay, now I have to rework my application. I have to put a proper service layer in place. I have to build an API. And, so my recommendation for people building Blazor applications is just build them client server.
Yeah.
Right. Like just build them so that they'll work anywhere. And then you can choose later how you want to actually deploy them.
Yeah. Well, and that seems to be a standard pattern across the whole industry, even with other languages, and the terminology of some people call themselves a front end developer and a back end. What they mean is the front end is like, no, all my stuff is running in the browser, and my integration with other things, quote unquote, is calling out from the browser to something.
Right. Yeah. And then there's this full stack developer as well, which is, I guess, a hybrid, someone who can do a little bit of front end and a little bit of back end. And, but yeah.
Which is how it used to always be until the split started being a thing.
And I think that's what Microsoft was somewhat targeting with Blazor, is they were hearing from development organizations that, it's really costly to actually have to staff two teams, right? A front end team and a back end team. And then there's like the inconsistencies and problems of having those teams communicate with one another.
Yeah.
Maybe it would be better to have one sort of cohesive tool set where the same developer can work on the front end and the back end and be productive. And that's what Blazor actually allows you to do. So I think it's accomplished that goal. The interesting thing is I think it still hasn't probably made a large enough dent in the industry as Microsoft had hoped it would, meaning like there still is a huge number of people that want to build applications using JavaScript frameworks, because that's just what's comfortable to them. There's
it had such a head start, in the SPA world.
Yeah, and no doubt, like they're very mature at this point, so they're super powerful and you can build
Mm-hmm.
great applications with them. But there's a lot of complexity in those applications that you're not going to be able to get away from.
Yeah. And architecturally, I always come back to that. If the technology choices of the broader software system were TypeScript, and there was TypeScript with Node.js running everything on the back end on the servers and calling out to a database and other things, then a fully TypeScript application, including AngularJS, that would be highly cohesive, and there would be a consistent tool chain for builds and tests and libraries, and there would be some portable code, logic and objects that could be in JS libraries on the server as well as in the browser. And but when you have a language and runtime split within a single application, where one piece of it, effectively one layer of your interior client server, one layer, it's a totally different tool chain than another layer. Well, now you have double the development environment overhead, and I don't see the return on that investment.
Yeah. Yeah, no, you're right. I think so. When you're using the same technology on the front and back end, they call that isomorphic, right? Isomorphic applications, where if like you were describing Node.js paired with like TypeScript and Angular or React or something on the front end, right? At least you've got sort of one common language for the whole stack. But when you there's a lot of organizations that are not using that approach. They're using like JavaScript on the front end and they're using .NET on the back end. And then you have like this dissonance right between the two. And yeah, that can create a lot of challenges. And a lot of inefficiency.
And duplication. Because, I mean, just think about basic rules and validation of update. Someone gets married and she needs to update the last name. That happens all the time. I'm updating a customer record. I'm literally updating one field. There's going to be some validation logic that's duplicated in TypeScript in Angular on the client before we choose to call the web service, because we're not going to just pass that back. Typically, do some little validation. And then in .NET, we got to have it again. So we got to have the logic in two places. And we know what happens then. There's going to be a bug somewhere, and we're going to fix it in one place, but we're going to have duplication in a totally different programming language somewhere else. And we're going to have the bug still hiding.
Yep. Yeah, not the greatest approach, but I guess it was early on. I think the challenge was that people were needing a better user experience, right, for the end user. And so the full page refresh model just wasn't working. And so that's created like the emergence of these JavaScript frameworks, right, to create these single page application, basically felt like a desktop app in a web browser. And that was like amazing. But in the process, you had these great front end frameworks that were emerging without much thought about what was happening on the back end.
Yeah.
And,
well, it was
not
amazing.
Much integration.
Yeah, we had the Ajax on the front end, which was updating little bits, and then we needed those SPA frameworks, and then because all the browsers had the JavaScript runtime. What could you run in a browser? You could run JavaScript, and that was it. It's like, okay, given that that's the constraint, given that that's the only thing that we can run in the browser, okay, we as an industry need to invent some frameworks that can live within that constraint. Well, now that constraint's gone with WebAssembly. It doesn't even have to be .NET, but architecturally that constraint is gone. And now I think, it's time to undo. And I think development leaders, in my opinion, regardless of what the decision is, architecturally need to realize that having two different code runtimes and code languages within the same application on the same team is unnecessarily expensive.
Yep. Yeah, expensive, inefficient, and long term, a problem. Yeah.
So it's like either do it all TypeScript front to back, or do it all C# front to back. Choose one.
Yep. No, I agree. Yep.
So tell us about Octane. We haven't gotten. I want you to touch on Octane. I know you're doing a lot of work, and you've got a lot of customers that are running it. And we did on the last episode, which I'll include a link to, talk about its heritage and the .NET thinking about the component model. But Octane is Blazor. So for the listeners, when should they say, "Oh, let me go use Octane"?
Well, yeah, and so Octane it has similarities to .NET meaning like it has the ability to build websites with it or web applications, and people, or blends of both. And often, a web presence will contain, static pages that are part of it, but also some interactive elements to it as well. So it can do all of that. I think I think the ideas behind building Octane was that there's a lot of sort of foundational plumbing that is part of every application. Like, for example, managing users or, logging or like there's just all kinds of these sort of plumbing aspects of things. And when I spun up a Blazor application from the template that Microsoft provides.
Mm-hmm.
I'm sure you're familiar with that. There's basically like zero functionality in
Yeah.
it, right? It has a few components. It doesn't even show you how to like hook up to a database. It's got basically nothing there that would help you build a real Blazor application. So I was thinking like, okay, well, I can make a framework that is a whole lot more productive as an experience for developers to use, right? Give them a whole lot of the conventions already baked in, give them a lot of the plumbing that they're going to need. Um, and that journey started in like 2018 with a POC and has evolved since then. And one of the goals was always to kind of keep up with the innovations that Microsoft was doing and allow developers to take advantage of all of the capabilities of Blazor. And so that's been a bit of a challenge, but at this point in time, like we basically have Octane is an application that can support Blazor Server, Blazor WebAssembly, Static Blazor, and Maui all in the same code base without like weird conditional compilation or any like tricks like that. It basically it's like an example of how you can build a Blazor application that satisfies all the requirements and
Nice.
like unleashes all the capabilities of Blazor. So that plus it has the things that are difficult to do in .NET, and Microsoft doesn't really provide solutions for, like multi-tenancy.
Mm-hmm.
Um, Modularity. And I know you can build modular applications in .NET, but when I'm referring to modularity, I'm talking about like building multiple distinct projects and then having them, composing at runtime into a single application, right? This whole notion of like micro front ends, right?
Mm-hmm.
Where you have a bunch of different applications, in fact, that are all deployed, but then at runtime, they're assembled based on configuration to create your UI, right? So not statically linked together, hard coded, tightly coupled, right? A very loosely coupled architecture. And that gives you a lot of flexibility. But it also comes with a lot of complexity in building such an application. And so Octane tries to abstract a lot of that complexity away from developers so they can just focus on the business capabilities of it. And so, yeah, we just actually had a release yesterday. It was the 6.1 release. So I've also been able to keep up with every .NET release. So,
Nice.
like when .NET 5, 6, 7, 8, and 9 came out, we had a version of Octane available almost on day one. Um, and so the upgrade story of .NET has been pretty good when it comes to Blazor. There
Mm-hmm.
hasn't been a lot of breaking changes since the very, very early stages. And that's been great for developers as well, because you don't want to like Angular. I don't know how many times we've had to rewrite Angular applications, right,
Yeah.
to adapt to like the latest versions. It's a
Right.
painful process and it's expensive.
Yep.
And clients are like, it's so expensive that clients are like, I don't want to upgrade. And I'm like, well, you're not
Yeah.
going to be able to take advantage of the new features or the security patches.
Right.
I'm okay with that. I'm like, okay, well, that's a bad idea.
Yeah.
Right. Whereas with Blazor, the upgrade path has been so fluid that, it's just been much better for clients.
Yeah. So Oqtane.org.
Yep.
Octane.org. We'll include that link in the show notes.
Okay.
And also, as we close out, how can the listeners check out and find the TrailBlazor Conference.
Yeah, so we hosted a TrailBlazor conference last year. It was it was a good virtual event. We were partnered with C# Corner and Sync Fusion. And we actually had 3 speakers from Microsoft. So Daniel Roth and Beth Massey and McKinnon Buck all joined us, as well as a number of other famous, I guess, .NET speakers as well. So it was a conference that was focused on Blazor and .NET MAUI kind of technologies, and also, I guess, had some sessions in it covering Octane as well. But it was seemed like it was a very successful conference. Everyone enjoyed it, and so we're going to have another one this year. We're thinking of having it mid-year, maybe around June timeframe, and we're just in the planning stages of it currently. But yeah, excited to do that as well, because I think it's great to have these focused conferences, right, where they're focused on specific technologies for those people who are highly interested in those technologies.
Yeah. And we can find it at trailblazor.net, Blazor.
Yeah, so all the recordings from the last conference are all posted there, so you can watch some really interesting content.
Perfect. All right, we'll include that and encourage the listeners to go check out those recordings. But
Cool.
Well, Shaun, thanks for coming back on the podcast and sharing with us about 7 years of Blazor and counting in the world of .NET SPI applications. Thanks so much.
Yeah, thanks, Jeff.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.